Hey, I'm Hannah Mae, and this is my chapter 10, chapter template review. This chapter was called Indirect from the Sun, and talks about water, wind, biomass, and it just talks about all the different renewable energy sources like hydropower, wind, and biomass, and how they're all clean alternatives for fossil fuels, but they, of course, had their challenges, um, that we'll talk about more later in this video. The U.S. Renewable Fuel Standard or RFS was brought up too in this chapter, but it has a huge impact on these biofuels, which causes conflicts between the oil industries and agribusinesses. The first section in this chapter was called hydropower. This one just talks about how hydropower is a clean energy source, but it does have um, significant environmental and social impacts. The consequences of large-scale dams were also discussed in this chapter. Some environmental impacts that were brought to our attention was altering river ecosystems and how dams transform these rivers and it affects all these ecosystems. Um, some social impacts include displacement of communities from this dam construction. So a lot of it results from these dam constructions and it causes a lot of problems in communities and ecosystems and especially wildlife in these rivers or in these bodies of water. Um, so many of these, like especially fish, are affected by these dams. In the chapter, salmon was brought up because they can't navigate through all the obstacles that are brought to their habitats or ecosystems in the water from these dam constructions. This brings me to my first diagram, and I thought it was just very important to show because it represents all the different types of indirect solar energy that is used. This, of course, is just all the other um, indirect, and here is what makes up the indirect solar. And as we can see, the one that's mostly used is hydropower. And then there's biofuels, wind, and I didn't even know this was one of like the energy sources, which is wood and waste. I didn't know that was used, probably because it's the least used. Um, which brings us to our next section called wind. We talk about the first few subheadings: wind resources, harnessing wind energy, and the impacts that it has on the environment. In these first sections, talks about how wind has grew and evolved over the last few years, and it's just going to keep growing as a source of electricity. It is clean and doesn't hardly emit any carbon or greenhouse gases, but it does have its challenges like mechanical issues and varying wind speeds. They do impact the environment because of the how much noise that they put out and even could cause atmospheric effects, even though the more larger ones are quieter. Wind energy is actually an indirect form of solar energy, and it has been used for years, and it is rapidly growing and evolving here in the past little bit. But some environmental impacts that were discussed, like land use, because they're usually like grid scale and use a lot of land because they're huge, and the visual impact, noise pollution, and could even cause like it could be potentially cause environmental, alterations to the climate. The last half of this section of wind talks about like the current state and the future of wind power, and it is including the already established technologies, but most of these are just concepts right now, and they're in the development development stages. Um, Historical development and growth of wind energy and how it becomes more competitive with fossil fuels to become a source of electricity. Brings us to the AWE or airborne wind energy. This one is just an emerging technology that can get to the higher altitude winds, and the historical development of wind energy talks about how it has grown since the 1970s, but it's in the lead of Europe, or in more specific terms, Denmark. Um, China obviously leads the production of wind power and the installations. That doesn't really surprise me because I feel like their technology is just so advanced compared to everyone else's. This brings me to my second diagram. I thought this one was good to choose because we were talking about how it has been growing and it's been evolving throughout the years. And this one shows a little past a decade ago from 2010 to 2022. And it shows, and I'm more of a visual learner, shows how it has went up exponentially over the past little bit. And I thought it would be good to show. Excuse me. Um, this section is called biomass. And we talk about the first few subheadings again. This one just talks about how biomass has been used since fire was discovered, and photosynthesis actually plays a huge role in storing the solar energy in Earth's biomass. I didn't know, and we've learned about photosynthesis since we were in like fourth grade. And but it really just exceeds our current energy use. Um, Biomass can be converted into various forms of energy, like ethanol and biodiesel, that can be used in vehicles and stuff of that nature. And by using biomass as an energy source, we could cut down our carbon footprint once again, because it wouldn't emit many greenhouse gases or carbon. Um, there are challenges associated with this source of energy, though, like land use, the competition for resources, and they're even concerned that it might be not as sustainable as they may have thought. The second half of this section of biomass, the last few subheadings are just talk about how biomass fuels, when they're combined with CCS or carbon capture and storage, it can actually reduce the emissions of carbon that much more in the atmosphere. The process of photosynthesis actually absorbs carbon from the atmosphere. We know, like plants use carbon and they turn it into oxygen. We've learned that since we were younger. CCS actually captures carbon during this process of biomass, and it stores it underground. And this could just overall help us to get away from fossil fuels and all of the bad negative impacts that it has on our climate and environments, just everything, and help address global warming. This next section is one of the last ones. This one just talks about all the other indirect solar energy sources, like ocean currents and waves. Did not know that was an indirect solar energy source. And which brings us to the OTEC, or the ocean thermal energy conversion. Excuse me. And this process just gets its energy directly from the sun. I didn't know all of these would be called indirect solar energy sources. I don't know why they're called solar really, but these all these sources are driven by differential solar heating. OTEC actually uses the temperature between like the warm surface water and all the way down to the cooler, deeper water. And it is a promising source of energy. It does have a lot of potential for in the future as a renewable resource, but its thermodynamic efficiency is actually really limited right now. And I think it'll get better after there's more like testing and just knowing exactly what is going on. And just a better understanding of it would just help a lot. Which brings you to this diagram. I chose this figure because I thought it was really cool, and like I said, I'm more of a I like to visualize things and see like what it actually is, and this gives a good like visual or example of what an OTEC would really look like. And it shows this at the top where it would get the warmer surface water, and then it has a pipe going all the way down to the deeper waters that are more cool, and that's how like the OTEC gets its power. And I just thought it was really cool to be able to show us something like that. This brings us to our last section it's the Science Meets Policy box, and it's called Biofuel Subsidized. This is the section that brings up the U.S. Renewable Fuel Standard, or RFS, and how it affects the biofuel production. The history and purpose of biofuel is also addressed in this, and just further um tells us about the conflict, like I mentioned, between the oil industries and agribusinesses. And it's mostly because of regulations and costs of things. Biofuel at first was used to stretch oil purposes and supplies, but now it's used to try to lessen our carbon emissions or greenhouse gas emissions. Um, RFS actually includes conventional biofuels, cellulosic biofuels, and advanced biofuels. Each of these have their target that they must like stay in or like get to of their own emissions. And the last thing, it just talks about the increasing volume of requirements for advanced biofuels over time, how it has just become more advanced and better overall. So yeah, basically this is an interesting chapter. We learned more about all of these new resources that could help us reduce our carbon emissions. Thank you.